welcome to the last page of 7.1 and 7.2. Glad that you made it this far. And what we're going to do is we're going to use Laplace transform to solve a second order differential equation. So here we have example 8, y double prime minus 4y prime is equal to 6e to the 3t minus 3e to the negative t, where our y of 0 is 1 and our y prime of 0 is negative 1. So we're going to go ahead and do our first step. We're going to Laplace transform everything that we can. So we're doing each term, and we're going to pull out any coefficient that we can. So for y double prime, we just do the Laplace transform of y double prime. For minus 4y prime, we're going to pull out the minus 4 and do the Laplace transform of y prime. For the right-hand side, we're going to pull out the 6 and just do the Laplace transform of e to the 3t. And then we're going to pull out the negative 3 or the minus 3, and we're going to have the Laplace transform e to the negative t. So after we do that, we know what the Laplace transform of the second derivative is. Go back 2 pages, we went ahead and did this, and it's s squared times cap y of s minus s times y of 0 minus y prime of 0. Then minus 4, and then we got to do the Laplace transform of y prime, which is just s times cap y of s minus y of 0 is equal to the right-hand side, which is 6 times Laplace transform of e to the 3 is 1 over s minus 3. And then minus 3, the Laplace transform of e to the negative t, it's just 1 over s plus 1. Now we have to do some substitution. We're going to substitute in for our y of 0's 1 and our y prime of 0 negative 1. So here's the substitution. On the right-hand side, I just cleaned it up a little bit, multiplied by the 6 and the negative 3, so just put them in the numerator. Now, after substitution, I do a little bit of algebra. I'm going to look for like terms, and I'm going to go ahead and combine them. Or I'm just going to clean up, the minus and the plus signs first. So this minus negative 1 is just going to turn into plus 1. Negative s times 1 is just, the minus s. And I'm going to distribute this negative 4, so it's negative 4s cap y of s. And then distribute a negative 4 to the negative 1, which is plus 4. Now I'm going to combine the like terms. And so I have plus 1 plus 4 is plus 5. That minus s, I'm just going to move to the right hand, a little bit to the right. And I'm going to put my y of s's over on the left-hand side because I'm going to group those together so I can pull out that y of s. So I'm going to move to the right-hand side at plus s and minus 5. So when I do that, just plus s minus 5. And then on the left-hand side, I'm going to pull out my cap y of s. So I'll pull the cap y of s out, and I'm left with s squared minus 4s. So to get cap y of s by itself, I've got to divide s squared minus 4s to both sides. And so we go ahead and we do that. And so we get cap y of s is equal to 6 over s minus 3, s squared minus 4s, minus 3 divided by s plus 1, s squared minus 4s, and plus s minus 5 over s squared minus 4s. Now, I want to clean this up. I want to write it all over one fraction. And so I do that. So I would need to multiply this 6 times a s plus 1 because that's not in the denominator. I need to multiply this 3 by a s minus 3 because that's missing in this denominator. And what's missing in the last term is a s minus 3 and s plus 1. So I got to multiply that s minus 5 by both of those terms. And so here I just show where I got to multiply the 6, negative 3, and the s minus 5 by. And then I do the math. I distribute, combine my like terms. And the numerator is going to be s cubed minus 7s squared plus 10s plus 30. All over s minus 3s plus 1s squared minus 4s. Now, because I have it all over one fraction, what I can do now is I can do partial fractions to simplify my equation, because then it would be easier to do the inverse Laplace transform to actually solve the differential equation. So I'm going to go ahead and get all my factors with their own fraction. So this has a factor, the denominator has a factor of s minus 3, s plus 1, and s squared minus 4s. And so I have s minus 3, s plus 1. Pull out an s from the s squared minus 4s. So there's just that s, and then I have an s minus 4. So those are my 4 factors. So they each have a fraction, and the numerators are going to be a, b, c, and d. And what we need to do is solve for a, b, c, and d. So in order for the left-hand side to look like the right-hand side, what I need is I need to have a common denominator for all of my fractions. And so what this a needs in the denominator is s plus 1 and s and s minus 4. So multiply all those by a, which you can see here. And then the same thing for b. I need s minus 3, s and s minus 4. So I'll multiply those by b. C needs s minus 3, s plus 1, s minus 4. So multiply all those by c. And then d needs a s minus 3, s plus 1, and an s. So multiply all those by d. Then I would have a common denominator with the left-hand side. So then I could just set the two numerators equal to each other. And so that's what we're doing. We're setting the numerators equal to one another. Now, what we need to do is we need to find a, b, c, and d. And the way that we're going to do that, again, is we're using partial fractions. So let's find the zeros for each of our denominators. And our zeros are nice because it's 3, -1, 0, and positive 4. So we're going to start off with s equals 3. Now, because s is equal to 3, I plug in the left-hand side for s3, I get 24. When I plug it in for all these terms, I only really need to look at a. The reason why I only need to look at a is because b has a s minus 3. If I plug in 3 for that, I get 0 here. Multiplication makes all of that 0. Same thing here. For c, s minus 3 right here. So I plug in 3, I get 0. So the whole term with c goes to 0. And also the same thing with d, because d has an s minus 3 with it. So I get a 0 here. So the only part that needs to be evaluated is really this a, because the 3 is going to make all these 0. And so I plug in 3, I get 4 times 3 times -1, I get -12. Then I go ahead and divide both sides by -12, a equals -2. So I found my a. Now let's plug in our next 0, which is -1 for the s plus 1. And so when I plug in -1 on the left-hand side, I get 12. When I plug in -1 on the right-hand side, the only term I'm going to have is b, because s plus 1 and -1 gives me 0, gives me 0, gives me 0. So the only term I'm now looking at is b. Plug in my -1. -1 minus 3 is -4. -1, -5, -4 times -1 times -5 is -20. So solve for b, divide by -20 to that 12, I get -3/5. For the third term, we have s is equal to 0. So again, on the left-hand side, I'm going to get 30. On the right-hand side, the only term that's going to stay is going to be c, because all these have just an s, and if s is 0, again, they're going to cancel out. So we're left with c, plug in 0, -3 times 1 times -4 is a positive 12. So to solve for c, divide 30 by 12, and we reduces to 5/2. And then lastly, the last term, I have an s minus 4, so my 0 with that is going to be 4. I plug in the left-hand side, I get 22. Again, all the terms are going to cancel out except for d, so I plug in 4. I get 4 times 1. I get 4 times 1 times 5, I get positive 20. Divide both sides by 20, I get 11/10. And so now, I'm going to go ahead and write my y of s in my terms of a, b, c, and d. And so if a is -2, so it's -2 times s minus 3. So there you see there. So if b is -3/5, it's going to be -3/5 times s plus 1. C is 5/2, so 5/2 times 1/s. And d is 11/10, so multiply that by 1/s minus 4. And now we do the inverse Laplace transform. When we do the inverse Laplace transform to the left, we just get back to our original. So instead of y of s, it's just y of t. And so I just go ahead and write y here. -2, the Laplace transform of 1/s minus, the inverse Laplace transform of 1/s minus 3 is going to be e to the 3t. Negative 3/5 times the inverse Laplace transform of 1 over s plus 1 is e to negative t. 5/2 times the inverse Laplace transform of 1 over s, which is just 1, so it's just 5/2. And then 11 over 10 times the inverse Laplace transform of 1 over s minus 4 is just e to the 4t. And so there is our solution to our differential equation.